Imagine waking up in the middle of a dense forest with no phone, no map, and no idea which direction you came from. Every tree looks the same. Every path seems familiar. Within an hour, most people would already be hopelessly lost. Now imagine a tiny desert ant. It leaves its nest, wanders hundreds of feet across what looks like an endless sea of identical sand, zigzagging randomly while searching for food. Then, without retracing its path or stopping to think, it turns around and walks almost perfectly straight back to a nest entrance barely larger than its own body. Or consider a homing pigeon released hundreds of miles from home. Somehow, it flies across unfamiliar landscapes and returns to the exact place where it was raised. Sea turtles cross entire oceans before returning to the very beach where they hatched decades earlier. Salmon spend years in the open Pacific Ocean, then somehow locate the exact river where their lives began. So here's the real question. How do animals almost never get lost? The answer is far stranger than simply having a better sense of direction. Nature didn't invent one perfect navigation system. It invented dozens. And many animals use several of them at exactly the same time. Let's start with something surprisingly familiar. Humans don't usually navigate by memorizing every single turn. Instead, our brains quietly build mental maps using landmarks. The grocery store on the corner, the tall building downtown, the old tree near your house. Scientists call these cognitive maps. Deep inside the brain are specialized neurons known as place cells and grid cells that help build an internal representation of space. Together, they allow us to estimate where we are, even when we're not consciously thinking about it. Many animals appear to use remarkably similar systems. Squirrels are a perfect example. Every autumn, they hide thousands of nuts across forests. Months later, after snow has covered the ground and erased almost every visual clue, they recover an astonishing number of those hidden food stores. Researchers once believed they simply smelled the nuts. But experiments showed that even when scent cues were minimized, squirrels still found many of their caches. They weren't following smells. They were remembering locations. Thousands of them. But this explanation immediately creates another mystery. What happens when there are no landmarks at all? That's exactly the challenge facing one of nature's greatest navigators, the desert ant. Its environment is almost completely featureless. Wind constantly reshapes the sand, leaving few reliable visual references. Researchers performed a fascinating experiment. They allowed an ant to find food, then quietly picked it up and moved it to another location before it started walking home. Instead of realizing it had been moved, the ant walked almost exactly the distance it believed remained before beginning to search for its nest. This revealed something extraordinary. The ant wasn't following a trail. It had been keeping track of every step, every turn, and every change in direction throughout its journey. Scientists call this path integration. Imagine silently calculating every movement you make while walking through an unfamiliar city, constantly updating your position without writing anything down. That's essentially what this tiny insect accomplishes with a brain smaller than a grain of rice. But even path integration has a weakness. Small mistakes slowly build up over long distances, which is why many animals rely on something completely invisible: Earth's magnetic field. Right now, invisible magnetic lines surround our planet. Most humans never notice them, but many animals appear to use them like a built-in compass. Birds provide some of the strongest evidence. When researchers experimentally altered the magnetic field around migratory birds, the birds changed direction accordingly. Sea turtles show similar behavior. A hatchling enters the ocean and may spend decades traveling thousands of miles before returning to the same beach where it was born. Researchers believe turtles memorize the unique magnetic signature of their birthplace, allowing them to recognize it years later. Salmon seem to do something remarkably similar. Magnetic information helps them navigate across the open ocean. As they approach their home river, another navigation system quietly takes over. Smell. Every river carries a unique chemical signature. Salmon recognize it and follow it upstream with astonishing precision. It's less like using one GPS, and more like switching between different navigation apps, depending on where you are. But even Earth's magnetic field doesn't explain everything. What happens when animals migrate under clear skies? Many of them simply look up. For decades, scientists wondered how birds,
managed to fly accurately over enormous distances. Then researchers created a planetarium experiment. Inside an artificial night sky, they changed the position of the stars. The birds changed direction too. They weren't memorizing individual stars. They were learning the overall rotation of the night sky. During the day, many birds use the sun instead. But because the sun moves across the sky, they combine its position with an internal biological clock. Without that clock, the same sun would point them in completely different directions throughout the day. Remarkably, experiments confirmed exactly this. When scientists shifted birds' internal clocks, the birds consistently flew in predictable but incorrect directions. The navigation system still worked. It was simply using the wrong time. Perhaps the most surprising part of all this is that many animals don't rely on just one of these systems. Homing pigeons appear to combine visual landmarks, magnetic information, the sun, and even environmental odors. If one system becomes unreliable, another quietly takes over. It's the same principle used in modern aircraft. Pilots don't trust a single instrument. They constantly compare several. Nature discovered that strategy millions of years earlier. But animals aren't perfect. They do get lost. Powerful storms can blow birds hundreds of miles off course. Artificial lights confuse migrating birds at night. Sea turtle hatchlings sometimes crawl toward brightly lit buildings instead of the moonlit ocean. The modern world is changing faster than evolution can adapt. Navigation systems that worked flawlessly for millions of years are suddenly encountering obstacles that never existed before. And yet, despite all these challenges, billions of successful journeys still happen every single year. Which brings us back to our original question: why don't animals get lost? The truth is, sometimes they do. But unlike humans, many species don't depend on just one sense of direction. They combine memory, landmarks, the sun, the stars, smell, magnetic fields, internal clocks, and mathematical calculations, constantly checking one system against another. Nature never built a perfect GPS. It built something even more impressive, a collection of imperfect navigation systems that work together so well that a tiny ant can cross an empty desert, a salmon can find the river where it was born, and a sea turtle can return to the same beach after decades at sea. Every one of those journeys is a quiet reminder that the natural world has been solving impossible navigation problems for millions of years.